This tutorial animation covers how a PN junction semiconductor works, what is forward bias and reverse bias, what is diffusion current and drift current, and what is avalanche breakdown, and how is it formed. It is a combination of P-type semiconductor with N-type semiconductor to achieve the practical utility of both. It's formed when a P-type semiconductor is joined to a N-type semiconductor. Now with the help of this animation, let's see how the P-type semiconductor and N-type semiconductors work. So the P-type semiconductor has holes which are positively charged, and the N-type semiconductors have electrons which are negatively charged. So you can see free holes which are positively charged are available in the P-type, and free electrons which are negatively charged are available in the N-type. So this is the region where the P-type and the N-type joins, or the junction which is formed, which is called as the PN junction. So this is the PN junction. What happens when a PN junction is made? Electrons near the junction jump from N-type semiconductor towards the P-type semiconductor, and holes near the junction jump from the P-type semiconductor towards the N-type semiconductor. This phenomena creates a space charged region at the junction. So this is a space charged region which is created at the junction. Electrons are available in the P region at this space charged region, and holes are available in the N region at this space charged region. An electric field is also created in this space charged region because of the movement of these holes and the electrons, and the direction of the electric field is from the N-type region towards the P-type region. Some electrons move back from P to the N in this space charged region, and some holes move back from N to the P in this space charged region. So it moves back also, and this continues to happen till an equilibrium is reached at this region. This movement of electrons and holes in the space charged region gives rise to a current, and this current is called as diffusion current. Now let's see forward bias. In forward biasing, positive terminal of the battery is connected towards the P region of the PN junction, and the negative terminal of the battery is connected to the N region of this PN junction semiconductor. And you can see the positive terminal repels the holes in the P region, and the negative terminal repels the electrons towards the junction in the N region. So a pressure is acting towards the junction, and this results in the junction to shrink. You can see the junction is shrinking there. Due to this repulsion, the depletion region or the space charged region narrows down, as you can see in the animation. If the voltage in the forward bias is above a specified range, these electrons in the N region drifts through the junction and migrates to the P region, and the holes in the P region drifts through the junction and migrates towards the N region, as like this. You can see the electrons are drifting through the junction towards the P region, and the holes are drifting through the junction towards the N region. Now the current starts to flow across the circuit, and this current is called as the drift current. Now let's see reverse bias. For reverse bias to achieve in PN junction semiconductor, the negative terminal of the battery will be connected towards the P-type semiconductor, and the positive terminal of the battery will be connected towards the N-type semiconductor. So holes get attracted to the negative terminal of the battery. You can see the animation over there, and the electrons get attracted towards the positive terminal of the battery as per the animation over there. So this result in the increase of the depletion region, the depletion layer, or the space charged region, because you can see the repulsion of the electrons and the holes is happening against the space charge or the depletion layer. So what happens is that this result in the increase of the depletion layer, as see in the animation. That's the depletion layer over there. Now the PN junction act as an insulator and will not allow any current to flow in the circuit. So this junction or this depletion layer now will be acting as an insulator and will not allow the flow of the electrons or holes in that region. But in a particular condition, if the battery voltage is above a particular limit, what happens is that this particular limit is called as reverse bias breakdown voltage. So if the battery achieves this reverse bias breakdown voltage, what happens is that electrons and the holes break down through the p-n junction and crosses this junction, resulting in the current to flow through the circuit. So you can see the electrons which are negatively charged crosses this junction, that is breaks through this junction and moves towards the p region, and the holes which are positively charged breaks through this junction and moves towards the n region, resulting in the flow of a current. This breakdown is called as avalanche breakdown. In this process, the current flowing through the p-n junction is very high, and ultimately the p-n junction gets damaged due to the overheating caused by this excess flow of current. This is how a p-n junction semiconductor actually works. So I believe you understand all the topics covered in this tutorial.